Hello everybody, my name is Jeroen Grift, and together with my promoter Claudio Persello and supervisor Mila Koeva, I created a paper called Cadastral Boundary Delineation using deep learning and remote sensing data, state of the art and future developments. And this PhD project is a cooperation between Cadastral and University of Twente, faculty of ITC. Shortly about the problem that I'm investigating. This will be familiar for you, I think. It's about the land tenure gap. So approximately 70 to 75% of the people in the world do not have access to a legal land administration system. And yeah, that has all kinds of negative impact on tenure security, agricultural productivity, and sustainable developments. And therefore, it's also related to several targets of the Sustainable Development Goals of 2030. Yeah, the lack of such a formal system is partially caused by technological issues. Conventional ground-based survey methods have helped developed countries build up countrywide cadastre with high accuracies, like also, for example, in the Netherlands. But this approach is too labor-intensive and expensive for most developing countries. It could take decades to complete. An approach that is trying to solve this problem is the fit-for-purpose land administration approach, which is also familiar for you, I think. And two main principles of this approach are that it's focusing on visible cadastral boundaries and acquiring these cadastral boundaries with satellite images and aerial photography. Well, those two main principles, of course, result in a growing demand for automated cadastral boundary extraction methods. And if you look at the recent studies on automated cadastral boundary extractions, you see that they are primarily based on deep learning in combination with remote sensing imagery. And well, they are showing quite promising results, I think. Here you see some examples. They're all based on relatively small areas, so that's the downside, I think. But the results look quite promising. The results show that less processing time is needed and fewer clicks are needed to create a final cadastral map, so that's nice. However, there's always room for improvement. A first one is that only a small number of deep learning architectures have been investigated. The current studies are mainly focusing on pixel-to-pixel translation by using, for example, a UNet, but the vision transformers, for example, which are quite popular right now, are not investigated yet. Next to that, current applications are mainly focusing on creating raster output and not vector output, and there are some examples in different remote sensing fields where vector output is created directly. A third one is an important one, I think. There's no cadastral boundary benchmark dataset available. And a benchmark dataset is important, I think, if you want to test different models in a standardized way and compare them. And yeah, that's not available right now. If you look at, for example, building delineation, large benchmark datasets are available. But if you look at cadastral boundary extraction, there's no benchmark dataset available yet. I think it's a good idea to create one. Next one is a bit related to the third one. It's unclear how trained algorithms perform on new geographical locations. It's also because we are focusing right now on very small data sets, but I think it's good to test transfer learning, for example, train models on data-rich areas and transfer the model to areas where not a lot of data is available and try to predict cadastral boundaries in those areas. Finally, delineated cadastral boundaries were not used to improve the predictions made by deep learning models. So if you create final cadastral boundaries, it's good to use those boundaries to create a better model. You can use the final cadastral boundaries to retrain a model and create better predictions. So that's what I wanted to tell you. Thanks for your attention.